Alright, welcome to tonight's video on Chapter 1, Section 5, talking about angle relationships, and we're going to define different types of angles. The first ones are adjacent angles. There are two angles that lie in the same plane and share a common vertex. And a common side. But they do not share any common interior points. So for example, if you look here, angle 1 and angle 2, actually let me draw a better picture of that. Draw it like that. Angle 1 and angle 2 are adjacent angles. Because notice they share a common vertex and they share this ray here as a side. A linear pair. A linear pair are a pair of adjacent angles with no common sides with the non-common sides being opposite rays. So if you look here, so if you notice angle ABD and angle CBD are a linear pair because if you look, BC and BA are opposite rays because they form a line, and these are adjacent angles, so therefore it's a linear pair. Whereas here they're adjacent, but this is not a linear pair because they don't form a line. Vertical angles are two non-adjacent angles formed by intersecting lines. So if you draw a pair of intersecting lines here, notice you have four angles. Well, angle 1 and angle 3, those are non-adjacent, so they're vertical. And same with angle 2 and angle 4. They are vertical angles. So another word for vertical sometimes people use are as opposite angles. Opposite. All right. So name the angle pair, or name an angle pair that satisfies the conditions that two angles form a linear pair. You could use PIU, or we'll do PIQ, and QIS. But there are others that you could use. Here, name an angle pair that satisfies the condition two acute vertical angles. So you could say PIU, this one here, and this one here, which is angle RIS. Name two adjacent angles whose sum is less than 90 degrees. Well, if you notice, CAD is here, that's 55, but DAE is 95, so the sum is not less than 90. FAE is 30, FAN is 55, so that is 85, so that is less than 90. Name two acute vertical angles. Well, if you notice here, FAN is 55 and DAC is also 55, so they are acute and they're vertical. Angle pair relationships. So vertical angles are congruent, meaning they're equal. And an easy way to tell is notice if you have a vertical angles here, and you say like this is 20, then this has to be 160 because it's a line. Then this would have to be 20 because of the line here, and then this would have to be 160. So notice their vertical angles are the same. So angle 1 is always congruent to angle 3, and angle 2 would be congruent to angle 4. Complementary angles are two angles whose sum is 90 degrees. So you could have angle 1 here, which equals 50, and then have another angle here, like B, which is 40 degrees, and they are complementary, because their sum is 90 degrees. They don't have to be adjacent, they don't have to be, there's nothing special, they just have to add up to 90. Supplementary angles are two angles whose sum is 180 degrees. So like angle 1 here is 120, and then like B here is 60 degrees. So they are supplementary, because they add up to 180. A linear pair basically also, the angles are supplementary, because a linear pair, remember, is two adjacent angles whose non-common sides are opposite rays. So angle 1 and 2 are a linear pair, and they would be supplementary. So here are these questions. Find the measure of two supplementary angles if the measure of one angle is 6 less than 5 times the measure of the other. So we'll let x equal the angle, and then 5x minus 6 is the other angle. And when you add those up, it equals 180. So 6x minus 6 is 180. You add 6, so 6x equals 186. So x is equal to 31, and that would be one angle. And then 5 times 31 minus 6 is the other angle. So 155 minus 6, which is 149. So you have 31 degrees and 149 degrees are the two angles. The next one talks about it when it's complementary. So x is one angle and 5x minus 6 is the other, but then it's equal to 90 because it's complementary. So 6x minus 6 equals 90. You add 6, so 6x equals 96. Divide by 6, and you get 16. So then 16 degrees is the one angle, and then 5 times 16 minus 6, so 80 minus 6 is 74 is the other angle. And notice they have to add up to 90. All right, the next concept is perpendicular lines. Perpendicular lines are two intersecting lines that form four right angles. So you know that not just that angle is a right angle, but all four angles are right angles. So in this picture, AD, the line AD, is perpendicular to BC. So when we write perpendicular, we put an upside down T. That means perpendicular to. All right. So moving right along here, if you want to find x and y so that KO is perpendicular to HM, KO, HM, so that means this is a right angle, so 3x plus 6 plus 9x equals 90. So 12x plus 6 equals 90. 12x equals, if you subtract 6, equals 84. Divide by 12 to get x equals 7. This is a right angle, so 3y plus 6 equals 90. Subtract 6, so 3y equals 84. Divide by 3, you get y equals 21. Or sorry, 28. So x equals 7, y equals 28. So here you want to find x so that AD and CE are perpendicular, so that means that's a right angle. So 4x plus 5x equals 90. 9x equals 90. Divide by 9 to get x equals 10. All right, so things that you can interpret from a diagram that you can assume. You can assume that points are coplanar. You can assume, like here, that G, H, and J are collinear because they're on the same line. You can assume the rays intersect at H. See how all these rays intersect at H. That H is between G and J. L is the interior of the angle MHK. You can assume adjacent angles. You can assume a linear pair, and you can assume that the linear pair JHK, and KHG here are supplementary. What you cannot assume is that rays are perpendicular. You have to know that they're perpendicular. You can't assume that angles are congruent, and you can't assume that segments are congruent. So looking at this picture here, can you assume that this is a right angle? So you'd see VYT. Is this a right angle here? And the answer is you can assume it yes, since because of this right here, you know that line XT is perpendicular to line VU. So that makes this a right angle here. Determine whether the following statement can be justified, that TYW, so right here, and TYU are supplementary, and the answer is yes, because it's a linear pair. What about VYW and TYS? Are those adjacent? And the answer is no, they are not adjacent. They do not share a common side. XAY is 90 degrees. I cannot assume that unless they told me that it was. Determine whether the statement TAU is complementary. TAU is complementary to UAY. Can be assumed from the picture, and the answer is no, it cannot. They'd be supplementary, you could assume that, but not complementary. Determine whether the statement UAX is adjacent to UXA. They are not adjacent. They do not share a common side or a common endpoint. All right, so a couple things I wanted to point out in the practice. Just looking at 7 and 8, find the measure of an angle and its complement. So if you let x equal the angle, and its complement measures 24 degrees more, so x plus 24 equals the complement. So when you add these together, it's equal to 90 degrees. So subtract 24 and you get 66. So x equals 33, which is one of the angles. And the other angle, 33 plus 24, is 67. Same thing here with supplementary. If x equals the angle, and x minus 36 would be the supplement. And when you add those up, they have to equal 180. So 2x minus 36 equals 180. You add 36 to get 216, divide by 2, and x is equal to 108. So that means the angle is 108. 108 minus 36 is 72. So those are your two angles. Alright, I hope this video has helped you. And if you have any questions, please feel free to